Hello and welcome back. We have been talking about binary, and this time we have gone over addition and how they represent each other. So, to quick refresher, let's say this is a ones place, which means there's one stone here. This is the twos place, which means that there's two stones here. This represents two, so you don't need two stones, just that. This is the four spot, which means that there are actually four stones here. And then this is the eighth spot, which means there's actually 8 stones right there. That's what that represents. And when we do an addition, it's as if we are putting, think of these, to like rehash this in a different way, because I've been, of how I've been saying it. So each of these is like a container. This only holds one stone, this only holds two stones, and this holds 4 stones, and this holds 8 stones. So it's always doubling up. So think of this as a cup. So every time you put another stone in there, it overflows and becomes 4 stones. The 2 stones moves into the 2 stone cup. But because there's already a 2 stone here, it overflows and gets dumped into the 4 stone cup. But because there's 4 stones here already, it gets doubled up and gets dumped into the 8 stone slot. And then this gets kind of dumped out because there's no more spaces after that. There's no more pencils. I could put more pencils there, but for the sake of this argument, it just gets dumped out. Like it gets completely removed from the board. And what that is called is it's called overflow. That is unsigned overflow. That means once these bits gets added together and it falls right off the map. It doesn't become 16 like if we were adding a thing. It just becomes blank. It goes right back to 0. And overflow is a very important topic that will be important when we're talking about signed binary numbers. So, what is a signed binary number? So we're talking about negative binary numbers of stones in this session. So we're going to first talk about sign magnitude. Let's say we have the number 6. How do we say this is negative 6? So we take the leftmost, how many pencils you have. Whatever is in the leftmost spot is not a number anymore. It just means that this is either positive or negative. Anything to the right of this one bit is a positive or negative, depending on if there's a stone here. So if there's a stone here, that means everything is negative. If there's not a stone here, it means everything is positive. So this is positive 6. In sign magnitude, this is negative 6. There is a problem with sign magnitude, and we will show you that right here. So when we do addition, we have a positive 2 plus a positive 6, negative 6. We have a negative here. So what happens when we do that? So that doubles up, goes to that doubles up, and goes to that. Well, for instance, we just kind of cleared the board. It became 0. That's one problem, because negative 6 plus 2 is obviously not 0. Let's do this a different way. So let's say 3 plus 1. Negative 3 plus 1. So if we push that down, these become 2. That gets pushed under that, gets moved over to that. And then we are left with negative 4. This is a 4. I'm pretty sure positive 1 plus negative 3 is not negative 4. There's a clear problem here. So sine magnitude is not good for addition or doing anything addition, subtraction. The only thing it's good for is representing the numbers as a negative. So we had to come up with a new way of doing things. So we're still going to use the sine rock, the sine bit. This is still going to represent if the number is positive or negative. However, we're going to do something different. We're going to do something called ones complement. So ones complement, what happens is we take these stones and then we invert it. So whatever is on here, we take the inverse. So wherever there's a stone, we take a stone away, and wherever there's not a stone, we put a stone there. So this is representing negative 2. This is actually a 2. So when you have the stones here, this is actually negative 2. And this works really well when you're adding and subtracting. So say you have positive 2 plus a negative 2. And you just move that down there, and then you invert it. You're left with a 0. That's great. Okay, let's say 4 plus 5 plus 1, a positive 1 plus a negative, it's negative 2. Negative 2 plus 1. So that goes down there. This goes up. These go up. That goes there. I almost messed up my carryover. And we invert this. Stone goes there. We are left with a negative 1. This represents negative 1 in one's complement. And I'm making that an emphasis on that because there is a problem with one's complement, as we were about to see. So what is this number right here? Let's invert it. We take all the stones away. What do we have? We have 0. There's nothing there. All right. Now, let's say we have this number. What is this number? Like, there's no sine bit. There's no sine rock here. This is also 0. So there are technically 2 zeros in one's complement. There's this one, and then there's this one. This is negative 0, and that's positive 0. That is a problem. So it causes issues later on when you're doing a bunch of stuff. So that said, what do? Well, they thought about it, and then they came up with something different. It's a little more complicated, but it makes perfect sense once you see it in action. So what they're doing is they take 2's complement is where they take the inverse just like in 1's complement. So they take all the stones away, and then they add 1. They add 1 stone. So this is actually negative 1. So when you see this, that's negative 1. And if we had this number, we invert it, leave that there, we add 1 more stone to it, and then that becomes negative 2. And so on and so forth. If we have this number, we invert it, which becomes this, and then we add that, it becomes negative 3. And if we have this number, we invert it, leave a stone there, and then we add 1, it becomes negative 5. And it works just the same if we were adding or subtracting. So let's say we're adding 3 to this negative 3, because remember when you invert it and you add 1, this should be 0. So let's add it together. So this knocks down, comes up to here. These knock down, move up to that. These knock down, move to that, and these knock down and become 0. It's just straight 0. All right, let's do a negative plus a positive. A negative plus a negative. We've done positive plus positive. We've done negative plus a positive. Let's do a negative plus a negative. So then, what are these numbers actually? Let's invert it and plus 1. Oops. Sorry if that was loud. Okay, with that, plus 1. So this is actually a 5. A negative 5. And this is actually a negative 3. So 5 plus 3, that should be an 8, which will give us an interesting number here. So this drops down, goes up to that. These drop down, comes up to that. And these drop down and come up to this. And this all gets knocked off. Which, you know, it kind of leaves an 8 here. Except there's a problem here. There's something called signed overflow. And what that is you get a number you didn't expect. Like you get a sign you didn't expect. It's easier to see when you're adding positive numbers. These are all positive, so this is just a 4 and this is a 7. And if you're like 4 plus 4 should be, we'll move this over. So what happens? This gets added to that. And on a normal thing, when this is like, when you don't have sign bits, when you don't have sign rocks, which means this rock represents a, represents that if this number is negative, we go back, the addition of 4 plus 7, knock that down, should be 8, 9, 10, 11. But that's not what this represents. This is not 11. This is actually negative 5 because we have to take the inverse complement and then add 1 to it. So this is negative 5. We got a negative number when we added these two positive numbers. That is a signed overflow. So if you remember at the beginning of the video, I was talking about how this plus this, knock that over, it just falls off the board. It just completely erases. That is unsigned overflow. And both of those can happen in negative numbers. But anytime you get an unexpected sign change, anytime a negative number plus a negative number becomes a positive number, or anytime a positive number becomes a negative number, or a positive plus a negative where the outcome shouldn't be negative or shouldn't be positive, that's when signed overflow happens. It's all kind of tricky stuff. And that's overflow, that's signed numbers, and that's unsigned numbers.